The number of novel antibiotics being brought to market has fallen off precipitously in recent years, a trend which, combined with growing antibiotic resistance, poses a tremendous threat to global health. This makes the recent discovery of a new antibiotic candidate exciting, but even more exciting is the method that Wang et al. Used to make their discovery. Most antibiotics we use are based on molecules made by bacteria. Bacteria have spent billions of years fighting each other, so it makes a lot more sense for us to take their weapons than to try to make our own. However, lately, our well of antibiotics from bacteria has started to dry up. So, scientists have started asking, how can we dig deeper? One promising line of inquiry, exemplified by the recent work of Wang et al., is to peer into the genomes of bacteria and see what they could be hiding. You see, when working in a lab, we are somewhat limited by the laboratory culture techniques at our disposal. Not all bacteria will grow in a laboratory setting, and even those that do won't necessarily express all of their genes. So, Wang et al. Surveyed thousands of bacterial genomes for biosynthetic gene clusters that could encode so-called antibiotic-producing non-ribosomal peptide synthetases. These aren't antibiotics themselves, but rather enzymes that bacteria might use in their biosynthetic pathways to produce compounds that have antimicrobial activity. They chose one promising biosynthetic gene cluster and used computational models to predict what sort of antibiotic compounds it might make. One, which they called Cilagicin, has shown promise in bacterial cultures, and an analog was even shown to work as an antibiotic in mice. However, in a sense, finding antibiotic candidates is only half the battle. For Cilagicin or related compounds to be used, they would have to be taken through long, expensive clinical trials. While finding a new antibiotic molecule might be what makes headlines, of more relevance here is the validation of a new paradigm for the discovery of novel antibiotics.